Hi, welcome to another Unity from Scratch tutorial. This is a new one in the mobile series, though what we're going to look at in this particular tutorial and the next one is very relevant for all types of game development. And we're going to be clicking on an object or touching an object and moving it around on the screen. So to begin with, we've got the same project that I created in the last few tutorials, and I've got this Touch Manager code. In the scene, I've got an empty game object called Touch Manager that I created, which the Touch Manager script is attached to, and I've added in 4 spheres. The camera at this point is also set to orthographic, so just take note of that. And we'll be looking at orthographic initially for moving objects around because the math involved is a little bit easier. And in the next video, we'll move on to perspective. So if you didn't watch the previous ones, I'll just show you where our Touch Manager code is going. And I've actually modified it a little bit and taken our code for generating our array that we're using to pick up an object and made it into a little function at the top, which is this one here. So what it does is it gets the position of the mouse cursor on the camera's near plane and the camera's far plane and basically draws a vector between them, which becomes our ray that we use for array cast down here to then click on an object and destroy it. So that's the code. Now if I just go back and run that, I'll show you what it does again. So if I click here, nothing happens. If I click on the spheres, it will destroy them. Now we don't want to destroy the spheres, we want to click on them and start moving them around. So let's just have a little bit of a look at the environment and the coordinate system that's going on and how we have to code in order to deal with that. Now, the nice thing about orthographic projections is that all the lines are parallel in them. So distances here at the near plane of the camera are same as the distances here back further in the environment, in the viewing volume, which is really great because that makes the mathematics quite easy to deal with in this case. Now, this is actually the most simplest case where the camera is actually facing down the z-axis of the environment. So if you were to click on your camera, you'll see that there's no rotation on it whatsoever. And it's the default camera looking straight down the world's z-axis. This will only work in this particular case, and when we start to move on to the next video and look at perspective, we'll develop something that will work in all cases. But for now, we just want to get our head around the math and what's going on in this particular case. So we click on the screen, which is here, and we then make that screen coordinate into a world coordinate. Okay, remember that they're different coordinate systems. We want to take that position projected out to the same distance that the sphere we're trying to click on is from the camera. Because when we click on a sphere and move it around the environment, we're going to keep it at the same distance from the camera and just move its Y and its X position. Okay, so it's going to move around, like this, staying at the same distance all of the time. So that will help us to calculate the actual position. So we use the mouse's position in the world, the mouse's X and Y at the sphere's Z value. And that's all we have to do. Right, so what does this look like in the code? First of all, we need to consider the 3 stages that the mouse or the finger touch is going to go through. So the first one is when you click down or touch down on something. The next thing is when you move while you still have the mouse down. And the other thing is when you actually release the mouse. So when you press down on something, let me just run this, which already has the code. When you press down on something, you want to grab hold of that object. And then when the mouse moves, you want to move the object with the mouse. And then when you release the mouse, you want to forget about that object and leave it where it is so it doesn't continue to move with you. That way you can pick up any object. And although I'm saying mouse lot and clicking, this works exactly the same for a single finger touch on a mobile device as well. Right, so what does the code look like? Let's go back into Touch Manager that I've now updated. First of all, right at the top, I've got a game object declared. Now, this will be the object that is used, the variable that's used to grab hold of the thing that we've clicked on. And initially it's set to null. Now, this does get set to null automatically when you declare it, but I've just done that here so you can see it. Now, when you set something to null, it means that that variable is actually empty, so that there's nothing in it. And what's nice about that is that you can test whether it's null or not, because if it's not null, if it's not empty, you've actually clicked on something. Now, the other code that changes in the Touch Manager here is down in the update, and you'll see the 3 phases that I just spoke about. First of all is when you first click down. The next one is when you just move the mouse, and the third one is when you release the mouse. So that's the get button up. Now I'm working with the left mouse button here, and this also will work for a finger touch as well. So get mouse button down runs in the first frame that you've clicked down. Get mouse button will run the entire time you've got your finger held down, and get mouse button up will run when you release that in that particular frame. Now let's look at each of these individually. First of all, we've got our get mouse button down, which is pretty much the same as we had before, except we're not destroying the object when we click on it. What we're doing, if you've clicked on a particular object, is we're setting our little variable that we created up the top to grab hold of the object that was hit. Okay, so now at this point we've got hold of it. Now if we continue to hold our finger down and we've clicked on something, as you can see here, then we can move the object around. Now that code, if I just expand this window for you to see, it looks like this. We're going to calculate the new position for the sphere to be the mouse's position translated into world coordinates. Transformed. I keep saying translated, but it's transformed into world coordinates. And then we're using the X and the Y from the mouse's world position, but we're using the Z value of the object's world position. So we're staying in that Z, we're staying the same distance from the camera. And after that, when you release your finger and you've got hold of something, okay, so this is what this little bit of and is doing here. It's testing that the G-obj is not null. And then when you release your finger and you've got hold of something, then it sets your G-obj back to null, so you actually don't have hold of anything anymore. So that when you move the mouse around, this here is not going to fire. Of course, if you've got your finger down on the screen, it won't fire. And that's pretty much all there is to that. Okay, so let's just go back and have a little play and run this. So when I run it and I click on the ball, it moves around following where the mouse is. But notice what happens if I click slightly off center and just hit the ball on the end. It snaps to the position of the mouse, which is a little bit undesirable, okay, because what it's doing is it's lining up the center value or the origin of that sphere with the mouse click location. But if you're moving these balls around, you probably want to be able to just grab it by the edge and then drag it around by the edge, not have it do that little snap. So at the same time that you click down, you want to calculate an offset value, which is this distance between where the ball is and where you've actually clicked, and to constantly keep adding that offset value on while you've got hold of the ball. So the offset value we will store up here. vector 3, and let's call it M capital O for mouse offset. And that's going to get calculated just after we've clicked on and picked up the object down here. So at the same time we grab hold of the object we've clicked on, we will calculate the offset. And that offset's going to be the difference between the position of the object that we've hit minus the hit point. So whenever you do a raycast and you hit something, you'll get the actual location of that point that was hit as a vector, so you can get that as well. Now that difference is that little offset. Now what do we do with that? Well, we're going to use it down here when we reposition the object by adding the x, mo dot x, and the y plus mo dot y to the x and y of the position of the sphere, but nothing to the z, because we still want to stay at the same distance from the camera. Just bring that out for you so you can see it all there. Okay, so that's the update function. All right, so save that and go back to Unity and press play. When we click, without moving the mouse, you'll see that the balls do not immediately move like they were before. Okay, so they don't snap to the position of the mouse, and it's really nice and smooth. Okay, so that's the picking up and moving of an object in 3D space with your mouse or with a finger touch and drag. In an ortho camera facing down the z-axis. If your camera is facing down one of the other axes, you'd have to adjust which axes the balls are moving on. So for example, if your camera was facing down the y-axis, you'd be moving the balls in the x and the z-axis. If you're coming from an arbitrary angle where you're not actually looking down any particular thing, it all gets changed and it's much more complex. So in the next video, I will talk about the perspective camera, how this works in the perspective camera, and then that will solve all of the problems of moving objects around with any camera at any angle.